I will tell you a story of a new renal disease. It's not every day that you discover or hear about a new renal disease. And this is a renal disease which was discovered, found by clinicians more than 20 years ago. And they found it in 2 countries. The first country was Sri Lanka, and the other one was El Salvador, Nicaragua. And what was happening that in these countries, thousands of farmers died of end-stage renal failure. And the typical phenotype of that disease was something special. Of course, they had a decrease in the renal function. They had no proteinuria. There was only, and if you look a little bit deeper, you could see some tubular proteinuria, but no glomerular proteinuria. They all worked in agriculture communities. In Sri Lanka, it was the tea plantations and the paddy rice, and in El Salvador, it was more the sugar cane. And there were no other causes of glomerulonephritis, polycystic kidney, hypertension, etc., were not present. So, from the beginning, most publications, and in the meantime, there have been a lot of them, explain the disease due to heat stress. The sun shining over the working place, and people did dehydration and heat stress, and developed a progressive chronic renal failure. And the other one, and this was very exceptional papers on that, there was some courageous investigators who told that maybe pesticides or agrochemicals could be inducing that disease. And that is still a huge debate. Today I will show you and prove this disease is due to toxic nephropathy, most likely pesticides. First, the arguments against heat stress. The arguments against heat stress are that the Sri Lanka people were using the paddy rice culture since more than 3,000 years. And they were using buffels, and they were using very primitive ways of doing the culture. And suddenly, in 1985, they were introducing for the first time the agrochemical substances. And 5 years later, in the history of that country, they found the appearance of that disease. So there was an extreme coincidence between the development of mechanical agriculture production using agrochemicals and 5 years later, an explosion of chronic interstitial nephritis in that country. A second argument I like very much is this one. We all know the man on the right side is one of my peers when I was a young fellow. This man introduced in Cuba the registration of all the disease, which is very well done in Cuba since more than 50 years. And still you can consult those registration formula since 1955 when he was Minister of Health under Castro. And here you see the flag of Cuba and El Salvador. These are 2 countries with exactly the same climate, the same altitude, the same latitude, the same crops, sugarcane. And the disease is extremely prevalent in El Salvador and Nicaragua. It's absolutely non-prevalent in Cuba. The only difference is that the United States put a ban, complete embargo, on the import of agrochemicals into Cuba. It's one of the most beautiful things the embargo ever has done. It has stopped the transport of agrochemicals and have saved hundreds of thousands of lives. But they don't know still what is occurring. The third argument is the enormous mosaic pattern. This is part of Sri Lanka. And you see in blue the paddy fields, in red the prevalence of the chronic interstitial nephritis in that country. And this area is completely comparable concerning climate, height, etc., etc. But you see that there is absolute, very small areas where the prevalence of the disease is very high. And we found out, together with our colleagues of Sri Lanka, that this is related to the use of low flow wells, wells almost very contaminated with high concentrations of many pesticides, which are used in the day-to-day drinking and cooking. And those with high flow and very productive water are not confronted with that disease in those villages. So this is a very nice argument that heat stress has nothing to do with that. And this is the last argument, and I think it's also a very good one. It's a paper from Pedro Ordunas from 1 year ago, and he did look to the prevalence of the disease in adults to the left and children to the right side. And you can see that the lines, the red line and the orange line, it lines from Nicaragua and El Salvador, compared to Cuba, Panama, United States. And you can see that not only adults develop chronic interstitial nephritis in those countries, but also boys and girls between 15 and 20 years of age start developing that disease. These children are not exposed to heat stress. They go to school or they stay at home. So this is a very strong argument against the heat stress hypothesis. We started from scratch. We started 3 years ago with our colleagues from Sri Lanka in collaboration with them and the colleagues from El Salvador and some other nephrologists. And we did more than 60 biopsies, renal biopsies, in patients with established renal disease due to chronic interstitial nephritis clinically. We didn't know the biopsies. So we did those biopsies, and we did several stainings, and one of the major stainings is a Jones stain, and we can come back to that, and later on you can ask me questions about that if you're interested in that. It's a classical stain for the basement membrane. Okay. And what we were surprised to see from the beginning, in all the patients with that disease, you see proximal tubular cells stuffed with these dark granules. And these are seen sometimes all over the cell, all over the tubule cells, or sometimes only in one cell. But that we saw repeatedly in all the biopsies we have examined until now of those patients with that disease have that picture. In the light microscope in the Jones stain. Here you see it from India, a patient from India. Again, at light microscopic level, you see all the stainings showing these huge granules inside of the cell. This could not be mitochondria. They're not the nucleus. There's really something else inside the cell who is growing. And you see here a section, a complete section through the proximal tubular cell, and you can see that this cell, the cell structure is atrophic, etc., etc. The next step was interesting, when you put the slides in the microscope to see the Jones staining on the left side, and you do autofluorescence, you see that exactly the same nodules, these granules, are autofluorescent. And in the body and in the nucleus and in the histology of the normal proximal tubular cell, you don't see autofluorescent of the nucleus, you don't see that of the mitochondria. It is something else, what was very fluorescent inside of these biopsies. We could show, and we tried to show, that this lesion was already present in the proximal tubular cell S1, S2, S3. This is S1. You see the glomerulus, and next to that you see the first cells of the proximal tubular cell, and you see the cells are stuffed with these granules, showing clearly that the first part of the proximal tubular cell, and also the last part, S2, S3. And we used for that two markers of the S3, intestinal alkaline phosphatase and LAP. And if you look to those cells, inside of the cells, having the marker of S3, you see the full-blown development of granules which are autofluorescent, and also on the Jones staining are very positive. So in addition to these intracellular granules, what was remarkable was that there was an enormous atrophy of the proximal tubular cells. And in addition, you see, and this is indicated by the arrows, you see apical blabbing and shedding of material. The cell is shedding himself into the lumen of the cell, of the sick cell being the proximal tubular cell. And you see that leads in the slide on the bottom of the left side, you see the prominent atrophy thick basement membrane, and interstitial expansion. So we have the characteristics of a proximal tubular cell suffering a lot and having not only intracellular granules, as shown here. This is a section of one tubular segment, and you see the cell is very flat. Normal, the proximal tubular cell is 3 times the nucleus. And you see that the nucleus height is comparable to the height of the cell. So there is an enormous atrophy because the cell is continuously shedding its own material out of the cell in order to protect them against this toxic substance. The last light microscopic slide has shown that in addition to this atrophy, in addition to this cell shedding and to these granules, we found that the proximal tubular cells indicated by the fluorescent green cells, the same section was incubated with pCNA, which is a marker of the proliferation. And this marker is absolutely absent in all the biopsies we have seen of those patients. If there is one cell in the body who has an enormous capacity of regeneration, it is the proximal tubular cell. If you touch the proximal tubular cell, you give a toxic substance, you give ischemia, and you do the biopsy, and you look to pCNA, it's full of cells trying to regenerate. In all those patients, we found that the regeneration capacity was stopped. The proximal tubular cell was not able anymore to regenerate. And we call that, for the moment, and we do very active research for the moment, we think that this disease is a proximal tubular cell disease where senescence is there. And senescence is something when the cell stops to regenerate. We are using the markers P16, P25, and beta-galactosidase on slices of those slides of these sections, and I hope to be able to tell you that in a few weeks from here. Let's go to the what kind of granules we are there. So we did the following. We stained on the left side with catapsin B. And catapsin B is an enzyme which is typical in the lysosomes of the cell. It's a very proteolytic digestive enzyme. And you see the positivity of the cell as shown in the insert. And this section is exactly the same as the Jones staining you see on the right side. And you see that the granules which are positive for catapsin B are the big granules in the cell. So these granules we found in all the cells of the proximal tubular cell of the patients with that disease are big abnormal lysosomes. Let's go further. We used in addition to catapsin B, we used LAMP1. And LAMP1 is a marker of the membrane of the cell. And if you incubate those cells, and you do the autofluorescence, where you see the granules, and you incubate that with LAMP1, you can see that there's a very nice red circle around the granule, proving that these are lysosomes because they are carrying LAMP1, a membrane protein of those cells. Let's go to the electron microscopy. And this is very important because you will see that this is the clue to prove that you have the diagnosis. We found in all those patients very strange lysosomes. These were not the beautiful lysosome. The lysosome is a very beautiful round structure of 0.5 until 0.67 micron, no more. We found big lysosomes, very abnormal, dysmorphic, and containing these red, very dark dots inside of the lysosome in all the patients who have that disease. Here you see another case of another, I think it's from El Salvador. On the top you see this cell, proximal tubular cell, with these enormous lysosomes which are more than 2 to 3 micron diameter and are completely dysmorphic, have completely lost the beautiful structure of the lysosome, and is stuffed with these dark granules. This is also an EM picture, and we could make many of them, showing the famous shedding. You see on the top, you see the normal cell with the brush border. And see there is an opening in the brush border, and the cell is expelling small particles of himself. And in these small particles you see again these dark structures, the lysosomes I have tried to explain to you a few minutes ago. These granules are not autophagosomes. These autophagosomes have a complete different picture as shown here in the different examples we saw. This is our finding on the lysosomes, and this is autophagy. These are not myeloid bodies like we know in the lysosomes of patients who have received aminoglycosides. This is completely different. The typical form of this myeloid bodies is this onion-like lipid layer, and this is completely different from our lysosomes. And there's also no lipofuscin. Lipofuscin is well known in the liver and sometimes less in the kidney, but if you look to the electron microscopic appearance of lipofuscin, this is what you see, and it's nothing to do with what we have seen. So in order to prove that this in the electron microscope, these big structures, which are very dark, are lysosomes, we did the Jones staining, and this is the section we have used, the Jones staining. We used exactly the same section, and what we did is we installed the, I'm sorry that I cannot start this, because it's very pity. This is electron beam grid, and you bombard that with the high energy electrons, and then you can absolutely determine on a very small surface of less than 1 micron the whole table of Mendeleev. So you can detect whatever element. And so what we were looking for was to see if these dark granules contained silver, because silver is the color you use in the Jones staining. And the Jones staining is staining very well the membrane of the cell. And you see there on the right side that this membrane of the cell was very positive for silver and gold. And exactly the same was found in the lysosomes. The lysosomes were very positive for staining for silver and gold, while the cytoplasma was negative. So this was the proof that the big dark structures we found in the electron microscope of our patients were indeed lysosomes. Abnormal lysosomes, increased in volume, completely dysmorphic and containing these granules. So we had to do, of course, if you find something new, you have to prove that it is specific and sensitive. So we collected many patients of different renal disease, from all types of renal disease, normal kidney with membranous nephropathy, etc., etc., etc. And we could find this. First of all, I will first show you what is the situation of our epidemiological studies. We found this disease in Sri Lanka, as shown there. We found it in El Salvador, and we found it in France, and we found it in India. And why we found it in France, what we did, we looked to the map, we received a map of France, where people from the European Commission have studied the pesticides content of the soil and the water in France. And you can see the map of France goes from yellow to orange and to dark. The darkest region being the highest contamination of that area with pesticides and in the soil and in the water. These dark structures are exactly the regions of the wine industry. And the wine industry in France is using the very huge amounts of pesticides during the cultivation of the wine. 20 to 25 times these wine cultures are spread with pesticides on average and having the highest concentration. So I contacted the different nephrologists there, working there. I just asked them, just send us blocks of biopsies of your patients where you found a chronic interstitial nephritis without clear explanation, without any diagnosis. And we received 5, 6, 7 of these blocks. 4 of them had exactly the same lesion as the patient in Sri Lanka and El Salvador. And when we had asked the doctors, do not tell us the story. And when we sent back our report, we said, number 1, 2, 3, 4 are probably people working in the wine industry. And we got the email back, you're right, this is correct. So this is the way we will try to detect that disease in many countries and also in Egypt. I will give the argument why we will do that. This is a paper of 2010 from the Elminia region. And I like this paper. It's simple but straightforward. They studied 216 patients with unknown etiology for end-stage renal failure. And they found, and they did also 220 controls. And what they found in the patients with unknown etiology, very high concentration percentage were from rural areas, where using unsafe water and using pesticides. So in your country, this disease is present, definitely. They were not lucky to do electron microscopy of the biopsies, but we will do that with colleagues from your country in order to prove that this disease is here. I visited already 2 years ago several villages along the Nile and in the region of Luxor and Aswan. I could make pictures, more than 25 different pesticides found on the ground used by the farmers. When you spoke to the farmers, they know exactly that this could be dangerous, but you're obliged to do that. Because if they don't do that, if they don't use them, there are no crops anymore growing very well. So this is an interesting problem, and we can discuss later on how we will approach that. So what is interesting, that in a normal condition, this is a normal biopsy of a patient with high proteinuria. And you see beautiful round lysosomes, absolutely not comparable to what we found in patients. This is something we were very disappointed when we found that, but very happy 2 minutes later. When we did the whole sections of all the controls of all the other disease, renal disease, we then found positive patients, not in glomerulonephritis, not in hypertension, not in diabetes, but one clinical condition, all the patients had that lesion. All patients transplanted of renal kidney transplant receiving cyclosporine or tacrolimus, which are calcineurin inhibitors. All of them showed exactly the same lesion in the lysosomes of their biopsy. This is one example. This is another one, cyclosporine and tacrolimus. You cannot make any difference between what we found in our patients with CINAC, of the patients with the farmers in Sri Lanka, and the patients receiving these drugs. And we know that this is a calcineurin inhibitor. What is a calcineurin inhibitor? It inhibits, in the middle of the figure, it inhibits the dephosphorylation on FET. And this blocks the production of active substances to promote rejection of very inflammatory substances are secreted by the cell. And cyclosporine blocks that by blocking calcineurin, which is a very important protein in the formation of those active substances. So the calcineurin inhibition is producing exactly the same lesion in the kidney of patients with renal transplantation as patients with this disease in Sri Lanka and in El Salvador. And we did a study in transplantation. We looked to patients, implantation biopsies, patients after 6 months, 12 months, and indication biopsies. And what we found, that by control, only a few had some lysosomes like that, but after 12 months, more than 80% of all our patients had that lesion. And if we look to indication biopsies, we found 76% of the patients. So calcineurin definitely inhibition is inducing that disease. And then we go to the literature, and we found very easily that a high number of pesticides are calcineurin inhibitors. And here is the list of all the papers we found, and there are many of them. I will not go over that list, just to show you. In the meantime, we have it proved in the lab.
Dear doctor, your time is up.
I will do just a few minutes. If you use the cell culture and you give catapsin, you give some pesticides like paraquat. Paraquat is a very popular pesticide all over the world. Well, you do perfectly calcineurin inhibition. So the circle was round. We have two conditions where this disease appears. Patients with pesticides, submitted to pesticides, and patients submitted to calcineurin inhibitors. Both pesticides and Cyclosporine and Tacrolimus are calcineurin inhibitors, and they induce exactly the same lesion, which is proof that this disease is certainly a toxic nephropathy. So what we do light microscopy of your patients on the top right side, and you see the big lysosomes already in the microscope, you can see them. But the best way, the only way currently to prove that you're right, is to do the electron microscopy. And if you find lysosomes more than 1.2 micron, you can be sure that this is a patient with that disease. One question was, did dehydration is doing that, because dehydration is the famous hypothesis of most of the publications. So we give to rats cyclosporine, control rats, and dehydration. And what you see immediately, controls on the left, cyclosporine on the right, with the beautiful lysosomes, and dehydration exactly the same picture as the controls. And if you look more closely, you find already in the cyclosporine rats, beautiful atrophy, big lysosomes in many regions after 5 weeks of treatment with cyclosporine, and nothing in the patients and in the rats who have been dehydrated. So dehydration is not inducing the lesion, which is pathognomonic for this disease. And here you see the normal lysosomes, and on the left side, you see already the right side, you see the big lysosomes completely dystrophic and very, very, very autofluorescent. I will skip that. We did proteomics and we found several proteins, and we are using.
Dear doctor, your time is up.
Find in the urine the absolute number of proteins which will help us. And I will stop here by saying, to conclude, that this disease, which is shown in different names, it's named CKDU, it's named Mesoamerican nephropathy, and we name it CIRAC, whatever, is the same disease. Because all over the borders, from Sri Lanka to India to France and to El Salvador, and we have now results in La Réunion, which is still a part of France, exactly the same. And we will go on, and I hope to be able with some of you, to prove this in Egypt, which is a very important issue. We have a diagnostic test. We have a common nephrotoxic pathway, calcineurin inhibition is the common pathway, and the herbicides and insecticides are absolutely calcineurin inhibitors. So I think we can go on, and we can use this for having the correct diagnosis in your country. And you see all the people of the world which until now have helped us to develop these ideas and to prove the diagnosis, the prognosis of this disease, and I hope that Egypt will join us very quickly. Thank you very much.